Good afternoon. Thank you for being here at a 4:30 p.m. session. I know it's probably your last session before beer or happy hour, right? No, yeah. So thank you. My name is Marissa Schmidt. I'm Senior Director of Product Management for Citrix ADC, formerly known as Netscaler. And I do have Netscaler shirts to give away. So we could do that throwing stuff to you or throughout, or you can ask questions at the end as well. I do not want to bring them home. So we do want to give all of them away today. And with me is...
Hi, so my name is Greg Dolan. I'm a distinguished engineer on the Netscaler sales engineering team. I've been here 15 years now. Pre-acquisition.
Right. Yes.
I still say Netscaler, and I will always say Netscaler, even though something's called an ADC now. Stupid corporate naming decisions. Oh, shoot, this is taped, isn't it?
It is taped.
Yeah, so the Citrix ADC is awesome naming. So, Hari.
I'm Hariharan Subramanian, and I'm the Citrix ADC product manager for public clouds. Been with Citrix for 10.5 years. Like he said, right, I also don't like Citrix ADC, but yeah, but Netscaler.
This will be the last time you see us. It was nice knowing you all.
Well, my title will still say the Citrix ADC product manager. Yeah.
All right. 10 years with Netscaler. Yes, I still call it Netscaler, and so is the 40,000 customers that we have. So it'll always be Netscaler to us. And that is part of the reasons why we're here, because being in the, I'm responsible for the cloud platforms as well as the on-prem. So part of this is really providing you the best practices for the public cloud deployments and with the Citrix ADC, right? So we go interchange between Citrix ADC and Netscaler, just how we are. But here's the agenda that we'll go through for today. It's giving you an understanding the differences between the public clouds, AWS and Azure in this case. And then we're also going to go through the elastic deployment approach from ADC perspective and sample of the public cloud deployments. And this is where really we'll rely on and Greg to give us from the field perspective. And that is part of that best practice as well. And the automation of the deployment your way, the way we have different automation tools, GitHub, and so all those details we'll get through today. And feel free to ask questions. You do want to be in the mic at the end. I was told you have to be in the mic because we're recorded. And then it depends on your question, then you can get a shirt, right? No, I really tried to get as much shirts, but we have around 8 to cover. So key cloud differences. We'll start with the system and networking parts. So what we go through in the Microsoft Azure, as you'll see in a standalone deployment in the marketplace, right? And then a VPX sizing, know all the different, the 4 vCPU, for example, the RAM, the 3 NIC, the output. And here in the Azure is up to 3 gig of throughput. Then in the network interfaces, what we recommend, so have this in your back pocket, as well as the routing parts by default, how it connects with the VNet resources, and for external access, how you do that with PIP and so forth. That's an important one. Then in the AWS, as you know, it'll be from EC2. And it's 8 vCPU is the recommended sizing. This can go up to 5 gig of throughput. So that's using the M4, 2 times extra large, right? So that's the one that we would look at. And 3 NIC and the outputs that you would do, and the recommended 3 ENI, right? And the VPC is what AWS really cares about here in terms of routing. Routes must be created manually between the subnets. That's an important piece to note there. Internal internet gateway, as well as the EIP route. Security rule, that is also an important one in the AWS. Then other key points is the actual how it's deployed, right? And the high availability, different scenarios you could do. Use the ARM, using the Azure ARM template, then using the functionality with 3 interfaces, right? What you need to do there in the front end for the ALB. And the INC mode as well with the same L2, and you need the Netscaler subnet IP and then NSIP. Shared VIPs is also required, as well as this one you really have to note that in Azure you have that 3-second failover. But when you look at the AWS, it's very different in this area. Yes, you deploy in the EC2, but you also need to do the floating EIP for the functionality piece for the HA. And to do the multi-availability zone, you need to do that, and separate also your subnet IP and NSIP as well. So the key point here in the failover is that it's a EIP integrated based on IP set, and it is longer. It's about 20 seconds versus the 3-second failover, right? So that is an important one. And now we're going to go through the details now. Azure, which Harry is responsible for, so he'll take it away. We'll go through here in the architecture pieces for Azure and AWS, then go through the deployments.
Yeah, thanks, Marisa. Mm-hmm. So the important points in Azure are, this is a typical deployment that we have for Azure. In case of HA, we use the ALB front-ending, which has the public IP address over here. So you can deploy the ADC on Azure in 2 markets, the commercial and the Gov. We have both. So active passive is very important. So if you have active passive scenario, you are an apps and desktop customer, Citrix customer, and then what happens is if you want to make it to in the public cloud, then you need to use the ALB for our HA. In case of standalone deployments, you don't need ALB. So that's one important point to note, that one. So to deploy this thing in both standalone and high availability, we have ARM templates, which is called Azure Resource Manager templates available, where you can put in either in availability set and availability zone. The difference between is that the availability set is in the same data center, different racks, right? And it gives you 99.95% of availability. And in case of availability zone, it's different data center. So if you see that there are 54 regions, probably, or 56 regions for Azure, you have availability sets everywhere. But availability zones, you have only 8, right? But it's good to go for availability zone. So there's one more difference over here is the ALB. ALB in availability zone is ALB standard you need to use. In case of availability set, you can use ALB free. One important thing I want to talk about, this is success in public clouds, right? So here is the backend auto scaling. So we always talk about elasticity in the cloud. So by elasticity, you mean that you need to be able to scale your backend servers as well as Citrix ADC. Here I'm talking about the backend auto scale. So using backend auto scale, basically it's inherent component of the cloud itself. In case of Azure, it's done through VM scale sets, right? And in case of Azure, it is auto scale group. So what you're talking about it, you set the properties in VM scale set to have 2 web servers, and you want to extend that to as many as possible based on the traffic that's being generated from the users or your users, right? So the threshold, you can say, hey, if 70% CPU reaches on the web server, you can scale out. Okay, if it comes below 70%, you can scale in. So this is the default architecture. Let me talk to you through in next slides to come on. And one more elasticity that we offer on Azure as well as AWS is autoscale, right? So in autoscale, we tackle both the front-end autoscaling, which is the autoscaling of your Citrix ADCs, and the back-end autoscaling, which is done by the VM scale set in Azure and autoscale group in AWS. So important components on the elasticity piece or the autoscale piece are Azure Traffic Manager, ALB, and Citrix ADM. You might have heard about Citrix ADM. That's an important cost. It's a single pane of glass where you can manage all your Citrix resources, particularly Citrix ADC resources. And ICA traffic is being generated. You can have SSL inside, HDX insights. Everything is inbuilt into Citrix ADM. I'll talk about the AWS. I want to show the AWS architecture over here. This is the same thing. The components in the AWS will be Route 53, NLB, and Citrix ADM also over there. So you can see that Citrix ADM is a single pane of glass. It's the control plane where you will go and configure all these things on both Azure and AWS. So let me talk about how this happens, right? What is backend autoscaling? What is front-end autoscaling here? So in this case, either AWS and Azure, as I said, in Azure it's called VM scale sets, and in AWS it's called the Azure AWS scale group, or autoscale group. So whenever traffic comes over there, always first the web servers will reach its potential, means the CPU will spike in web servers because Netscaler is capable of handling, or Citrix ADC, sorry, is capable of handling more traffic, right? So whenever the web server's CPU spikes, then what happens is that a new web server will be spun by the VM scale set itself. So once it's spun, then what happens is that there is a polling happening from the Netscaler to the VM scale set. It detects that if a new server has been deployed. If a new server has been deployed, it takes that IP of that particular web server and adds it to the service group on Netscaler. This is all automatic. So that's what here happens. And then in this next, that was the scale out and scale in. Let's see, the threshold decreases to 40%. And then what you're saying that the new web server that was created before is killed. It's no longer needed. And there is a connection draining property we have wherein we can wait for either the Azure or AWS to tell us that this server is no longer needed. I'm going to remove it from my list. Please do also. So we will wait on AWS to do the draining first, and then we will remove it from our service group. Okay. So this is a typical workflow. What happens if you want to set this up? This is available both on AWS and Azure. And if you want to set this up, you have certain prerequisites from both the Citrix ADM side and on the Azure or AWS side. So here, first, in case of Azure, you start with Azure over there. You have to create a VNet. In case of AWS, we have a nice template available where you can just spin up. It will create the VPC, security group, everything. So that's the primary requirement. And also from the Citrix ADM side, there should be a connectivity from the ADM to the Azure or AWS that we call as Cloud Access Profile. So you need to create that one. And once that is created, you go on with creating an autoscale group. I have a demo for this thing. After finishing that, I'll just show a demo of how this works. So the basic principle is that after everything is created, the traffic flows in. So first, as always, the backend autoscale or scale out will trigger. Okay. Once there are more web servers, at that point, Netscaler threshold will be reached. Then a new Netscaler will be spun, and it will be added to the cluster. Correct? So first, backend autoscale will trigger, and then the front-end autoscale will trigger, and the whole cluster node will be enhanced. One more thing I wanted to point out here. So we can maximum go up to 32 nodes in a cluster. That is same as what we can do in current VPXs. Okay, 32 nodes. So coming to deployment. So we talked to a lot of customers, and a lot of people are moving to both AWS and Azure. I have sample deployments for both. If you are Citrix apps and desktop customer, probably this is your typical deployment wherein you have a storefront in the cloud, and you have offices in different regions. Let's say Azure West and Azure East, over to cater both East Coast and West Coast over here. You can use a GSLB solution. This is an active passive, so you are using Azure load balance in the front, and you are using the capability of VPX's GSLB, right? Citrix ADC GSLB capabilities to load balance this across multiple regions. Okay? And typically, let me show the AWS deployment. In this deployment, you have the same thing. You have made sure that in this VPC, you have Active Directory, everything, delivery controller, storefront, everything is there. Or you can use Citrix Cloud for that one. So if you do that one, and you make sure Citrix Cloud Agent is running in your on-prem or on the Azure cloud, which is pulling all those Active Directory details and for your authentication needs. You also make sure there is a VPN gateway available. End users are trying to reach that one. There is also a possibility that you can use the Citrix gateway, which is available on Citrix Cloud. So ultimately, it depends on where your VDAs will be there or apps will be there. It can be on-prem or it can be on cloud, wherever you want to do that one. But this is a way where you can have an HA pair on your AWS to load balance. And the end user is hitting that particular VIP and accessing your applications and desktops. Okay. So one more deployment I was talking about before, that we have ARM templates and the CloudFormation templates. I just want to quickly go over that one here. In Azure, by the way, we recently released 13.0, but I'm still showing 12.1 over here. 2 weeks ago, there was a new build, together 13.0 release. We made it available to all the users. This is the Azure here. In Azure, you can log on to, and then there is a Create Resource button. You can search for Citrix ADC 12.1 and high availability. And we offer these different options for you to easily create the whole environment that you need, right? Availability set, availability zone, the backend autoscale. The backend autoscale, which I just explained what it can do, it'll ask you a few questions and it'll create the whole instances for you on Azure, right? These are the three, and it's super easy. It just takes 4 minutes to deploy whole of infrastructure. The one thing that we do not do, and we are not supposed to do, is invoking a 443 GUI management, basically. We do not do that one. Generally, our typical customer, what they do is they do not have want a public-facing management available. So either they are using an express route or direct route. Probably Greg will talk more about the deployments. But this is it in 4 minutes, whole deployment setup for you. Okay. We also have, and in case of AWS, we also have these templates in the CloudFormation template. We also make sure these templates we are regularly developing these things, and these templates are available in GitHub repository. We recently, 10 days ago, we updated this internal, that the ask came from our customers, right? I understand that right now your template offers only a public IP address for ALB, right? We do for HA pair setup. But my requirement is that we don't use ALB public IP. We are having an express route between our on-prem and the cloud. And I just want to use a private IP for my ALB. So we immediately did this thing, which is internal, HA3NIC internal deployment, wherein the ALB will use the public IP. Okay, so if you can give us feedback if you want to develop more, it is easy, quite easy to put this in place in this GitHub repository, and probably you guys can also contribute to this. It's very easy, these templates, and it saves a lot of time for you. I have done myself to have a manual seeing a Citrix doc, and doing that it need an hour to deploy all these things if you want to do manually, and with this template it'll be just 4 minutes. And the same thing is true also for AWS. So we have all these templates available over here, and you can use those. And let me give this to Greg.
All right. So that all sounds really cool, right? How many people are actually using any of this?
Raise your hand. Oh, he gets a shirt. Here.
Oh, you have.
Wow, I was trying out my.
I knew she was going to hit someone else. Good arm, though.
Yeah.
Got it farther than I thought you would.
Okay, I'm going to do another one. Okay.
So people are going to grow into this, right? I mean, that's the goal. We're starting to see more and more people are finding that their on-prem is doing fine, but they need to expand. Their management structure is all cloud, 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 and so they're playing with the cloud. They're starting to deploy things into the cloud, and it's becoming a reality. I bet if I asked the same question next year to this exact same group, I'd probably get a different answer. I'd probably get more hands raised. Some hands that raised might actually go down. It's pretty funny how the cloud evolution works. So let's talk about, from a customer standpoint, how this has worked and what it's kind of looked like for people. Haha. So what does a migration from on-prem to cloud look like? Migration is the wrong word here. It's one slide I forgot to edit. No one is migrating their entire workloads from on-prem to the cloud right now. I mean, maybe someone, but AWS and Azure certainly want people to, desperately. So they're coming to us and asking us to help them figure out how to do entire workload movements. The reality is people are moving partial things to the cloud. They're spinning up new websites. They probably have a DevOps community inside their company that they don't even know about, that's out there running Kubernetes in the cloud and spinning resources out there. They find out about it later, and then they got to catch up and figure out how to integrate with those Kubernetes environments. We've got some great sessions on that here, by the way, probably.
Yeah.
Just keep an eye out for anything Cheerdeep has to say. So this is making an assumption that you've already moved to pooled capacity. That's a funny question. How many people in here are using pooled capacity on their Netscalers? Sweet. All right, how many people in here actually have Netscalers? Thank you. All right, good. Arms work. People can raise them.
Was I supposed to? Oh, somebody wants a shirt. Is it that side or is it this side?
Yeah, let me see it.
Let me just throw.
Well,
Cool, thanks.
Wow.
dude.
I should have been a rugby player. Too
Okay.
bad I hate getting hit. So the assumption here is you move to pooled capacity. Reality number 2, over the next couple of years, I have a feeling most of you are going to be moving to a pooled capacity model. It's much more dynamic. It's actually easier to license your boxes with and a whole bunch of other stuff. It has its challenges, but the benefits outweigh the challenges once you get everything deployed and everything working. The next move like this is going to be dramatically easier. So we start out, we got the zero capacity hardware that's running on-prem with some capacity on it. I don't know why that just disappears, but we'll call it good. So we got ADM running on the top of all of this, which is necessary for the licensing server in the first place, but then it's also keeping things going on both sides of the infrastructure. So in this case, we've thrown 200 gigs on-prem and 50 gigs up to the cloud. So that's where we're starting. It's a good point. But then we've decided, hey, the cloud experience is actually going really well. We're having a good time there. It's actually lowering some costs. We're able to reduce some server infrastructure. Maybe we didn't have to refresh a bunch of server hardware that we were planning to. So let's go ahead and move even more up to the cloud. Now the implication here looks like we've gotten rid of everything on-prem, but that's not true. So the point is it was all portable. It was very easy for me to take some capacity off of on-prem and just move it to the cloud through the licensing server. All I had to do was tell it to do it. And I didn't have to go up to the Citrix licensing site and pull down a license and put in my MAC address and all that other fun stuff that goes along with it, which gets even more fun when you're spinning up 150 VPXs in the cloud and have to license them. Not a lot of fun. So pooled licensing really is the only thing that makes this all possible. Now, the other cool thing, that last example was using one version of pooled licensing. It was the instances/bandwidth method. So for every VPX I deploy or every VPX on an SDX or even an MPX, I have to deploy an instance, which tells it it can be a device. And then I have to deploy throughput to it, which tells it how much capacity that individual instance has. One of the new models, the recommended model for cloud services at the end of the day is honestly vCPU. So from 13.0 on, actually, did we add it to 12.1?
We have it 12.1 as well.
50 or next build or current build?
The latest of 12.1.
Okay, so 46, I think it is, something like that. Yeah.
51.19.
Yeah.
Is that out now?
Yeah.
Oh, sweet. Okay.
It's just the latest.
So, sorry, segued. So from the current releases on, you can now do vCPUs. One of the things that I will say we owe you is what does a vCPU mean to me? You know, how much throughput am I going to get out of one vCPU? How many requests per second? How much SSL? How much bulk? All of those numbers, we need to go grab a DL580 and run some tests on it and come up with some numbers so that you guys know if I deploy one vCPU, this is kind of my expected capacity. The nice thing is with vCPU, you can just multiply your capacity out just like any other VPX adding CPUs. What you don't have now is an artificial bandwidth limiter or anything like that. It will just do however much that virtual CPU can do.
So similar sizing that we would need also for BLX. So somebody's already asking me about that since BLX was announced yesterday. So we would need to do something similar in terms of sizing each of the CPU.
Yeah, we'll get it done. We'll get it published. So the nice thing is it's all still check in, check out. You know, right now, if you're deploying instances and bandwidth, the more bandwidth you deploy, actually, the more vCPUs get deployed. But it's an algorithm that's done. It's not actually distinct, right? The nice thing about vCPUs is you literally know how many cores you're taking up in an environment. It's a known, and sometimes it's nice to have a known instead of an ephemeral. And then, yeah, it's going to check out just like you would today. It's just a little bit different licensing model. So pooled licensing evolution is really what this is for the cloud. Right, the other cool thing, how many people out here use Terraform? That's okay, don't worry, sweet. Yeah, you don't count. So Terraform is just a programmatic way to deploy Netscalers or to configure Netscalers. So as you can see, if you go up here, we have a few Terraform templates up there. These are supported templates, so these are being deployed by the Netscaler development team. These templates also can be requested to be changed or added or anything else. You just got to make a request through your SE team to get anything added. Again, it's all up on Git. It's available to anyone. You just go to Git and it's there. Same thing for Ansible. Probably more people using Ansible.
Who uses Ansible?
Much more.
Yay.
I kind of figured that was the case. Yeah.
Oh, I'm getting better at this. You know, by the time I get to the 8th one, yeah.
So,
Actually, I'll just give one to him.
ah!
Oh,
Wow.
even better than that one.
Obviously, we are the sports team
Yeah.
crowd.
Yeah.
So Ansible, same thing. If you've got some requests for Ansible, please send them to us. Quite frankly, if you guys are creating your own Ansible modules and want to be part of a community, just deploy your Ansible modules for us and let us know. We actually want to engage more in the dev community and with the customers to make things even better. That's kind of a goal. So how do we look when we actually take automation and move into a public cloud shift? So in this case, we've got an on-prem system, and then we've deployed a cloud system. I've got end users that are connecting to both, so it's kind of your typical hybrid multi-cloud looking deployment. And I'm maintaining an umbilical between on-prem and the VPC or the availability zone through Direct Connect or Express Route or whatever it happens to be. So the cool thing here is what they've decided to do. This is actual customer deployment. I mean, I'm not just making things up. These come out of customer deployments. So they're using Ansible to talk to ADM. And then what ADM is doing is it's taking the language that Ansible's written in, it's injecting that configuration into itself, creating style books, and sending them out to the VPC ADCs or the on-prem ADCs for config changes. So the nice thing about that is your DevOps team, who doesn't necessarily know Netscaler, can just configure things using Ansible in a more friendly text to them, send it to ADM. ADM does the translation, builds the style books, sends it out. It's all beautiful, I think. We do make it sound a lot easier than it sometimes is. And that's when I'm talking about engagement with the community and more. We want to make this easy for you all, and we want to make it understandable for everyone. And that's a final goal. And that, again, it requires us to all talk and you guys to talk to your SEs and your sales managers and come up with suggestions. So the nice thing here is everything is automated. No one is logging into a Netscaler in this environment. And that is a goal of future Netscaler environments. You will never log into a Netscaler again, except maybe during your initial deployment of an MPX or something. Everything should be going through ADM. ADM is now your gateway to everything. So the cool thing about this diagram, we had a little scenario where in AWS and Azure, they were given a domain name as a reference, but the EIPs are dynamic, so they can change. So what we had to do was come up with a solution that could dynamically handle those changes and make sure that availability was still there for the end users connecting to the site. So in this case, they have an on-prem and 2 cloud deployments. And then what you look at is we're not actually the load balancer in this solution up on top, up in the cloud. They're using ALB. Actually, I love how we say ELB. The reality is they're using ALB in both sites because Microsoft and Amazon decided to use the same acronym for their load balancer because, well, that's just the way they work sometimes.
It's ELB.
ELB is the family.
Yeah,
NLB and ALB are the
Yes.
actual load balancers.
Yes, that's right.
So in this situation, what the Netscaler ADCs and the GSLBs are doing in all the locations is really handling the dynamics of the IP changes and making sure that there's no DNS blackouts, nothing's getting lost. So when a Citrix ADC in the cloud gets a request for a DNS resolution, it has the most up-to-date IP address that is owned by the ALB. The other side of it is ALB is auto-scaling. So as it auto-scales, no more A records are getting added to the Netscaler's GSLB dynamically, and it's still maintaining MEP between the sites and maintaining all of those new A records that come in. So what it does is it allows us to be cloud native, and it helps, in this case, to simplify hybrid multi-cloud for the customer. They could do this without Netscalers up in the GSLB locations. It would just be a nightmare. I mean, trying to handle all those DNS changes, how do you update your DNS infrastructure to make sure it's all... We took care of that for them as part of a solution, and this was actually an RFE that was completed when?
In Q1?
Q1? Yeah. So this is actually a fairly recent thing. I found out about it this morning. But yeah, it's there, it's cool. If you're not super busy in the cloud right now, you don't understand necessarily why it's important. It's very expensive to have a static IP in the cloud.
Yeah.
So what this allows you to do is it's actually cheaper to run the Netscaler GSLB device and use non-static IPs than it is to have static IPs and run standard DNS. So that's the end use for this, was just really to save money in their deployment. Now let's look at a more interesting deployment and something that is becoming more common and should become more common. And this is going to be sort of an image of what everyone's HMC deployments will likely end up looking like over the next few years. You'll have your on-prem and your clouds, but now you're going to have to distribute the traffic. So here's the real fun question. How many people in here are familiar with ITM?
They don't count.
That's a few.
That's
How many people are familiar with Sidexis? Yeah, more names came up. That's funny. See, it's interesting how that works, right? So we purchased a really awesome company named Sidexis and got to get hold of their really awesome GSLB solution. So what it is, it's hosted DNS, and then it's also a massive amount of real user data that helps direct your traffic properly around the internet. Unlike our typical GSLB that we have, which is, let's be honest, kind of dumb. It knows who your LDNS server is, and that's about it. And so it makes some...
Except customers still use them, but
Right,
the
they do.
integration with the GSLB with ITM will make it better.
There are very good use cases for GSLB. GSLB will always know what's happening on the load balancer back. ITM knows what's happening from the load balancer to the client.
Right.
Use them together, and all of a sudden, ITM becomes aware of what your server capacity is at a given site, and so it can actually downrank a site if servers start dropping like flies. And at the same time, ITM is very aware of what's happening on the internet. So here's an example. I live in Renton, Washington. I'm on Comcast internet, and I live on Field Avenue. Say Marissa's my neighbor, and we're both accessing some of the same stuff. Well, I've already gone and accessed it, and ITM already knows what my experience was to different places on the internet. And ITM knows what the experience was for every single person in my neighborhood on the internet already. So when Marissa logs... Huh?
What were you accessing?
Doesn't matter.
Oh, okay.
We have probes everywhere. And the cool thing is all the major cloud providers are inserting the tag, so all that data is being collected for all the major cloud providers already from every geolocation. It's actually really freaking cool. But at the end of the day, when Marissa comes and logs in, she wakes up later than me because, well, it's Marissa.
Yeah.
I try to get hold of her at 8 a.m. every morning, and she's like never responds.
We know each other too well. Can you tell? 10 years. Oh, anyway.
So the cool thing is when she logs in and starts doing things, instead of GSLB having to make some new decision, it already knows. And so she already gets the best experience from the start. So we're finding with ITM deployed in front of websites, we're seeing a rough worldwide reduction of how much in latency? Yeah. Customers who deploy this can see up to 50% reduction in worldwide latency for their sites, because we stopped doing stupid things with DNS, like I live in Seattle and my GSLB solution decides to send me to Singapore for DNS resolution. That's a 1-second DNS resolution, not a good experience. I haven't even gotten to a website yet and I've already spent a second waiting. I don't know about you guys, I started hitting F5 at that point. Just DOS my website. So ITM solves that because we stopped doing stupid things with DNS resolution and start doing everything very intelligently. If you haven't gotten the idea here, go ask your sales teams about ITM.
Yeah.
Anyone? Yeah? Cool? All right.
Yep.
If you haven't heard about ITM,
They have a
I'm going to have a talk with your sales teams already. What's that? They're
Yeah.
supposed to.
They're supposed to. That's why we have.
It's a
these
good
sessions,
question,
you know?
though. We've had a lot of training on ITM. I mean, so there's some deeper stuff that they're not going to understand, but that deeper stuff's not relevant right off the start. I mean, right from the start for free, you guys can all go log on to the page and you can get a heat map of what the internet looks like around the world based on selection of, say, Azure data centers or AWS data centers. And you can go, oh, well, okay, I want to go into Europe and I want to have the best experience. So I'm going to open a data center in Europe, and that's going to change that heat map to show you what the average user experience is. This is live and real-time data that you're looking at that point. You can then see what it looks like with geo-based GSLB, you know, your standard every day. And then you can turn on the ITM tag and watch the heat map get even cooler. And it's real data. That's the best part about it. There's nothing that's made up about the whole thing. Where should we go with this?
Next slide.
The next slide is kind of boring.
Well, that's we need to get some time for their Q&A anyway.
I was trying to take up their Q&A time.
Thank you. So there are a lot of, as you can see, there's a lot of documentations that we've done and automations that are in GitHub. So definitely look at all of that information. And my ask for you guys too is to provide, you know, positive reviews of your experience in AWS and Azure, because we could really use some of that information and knowledge in there as well. And actually in AWS alone, we have over several thousands of customers, and in Azure, because of our partnership with Microsoft, we have over 5,000. So any of those information that you know of and you want to share some of that positive experience, please provide the reviews, which he will look at on a regular basis.
Well, and one really cool thing, just to bring up real quick, Marissa,
Yeah.
the cloud providers themselves are actually, like I said earlier, coming to us and trying to help figure out how to move workloads better. So we're working with AWS and Azure to actually create templates to take an entire Citrix infrastructure and in relatively few clicks, deploy that entire infrastructure to the cloud with the gateway and everything else already working, connected to your Active Directory on-prem. That's in process. That's going to be coming very soon. So people who are hesitant to move to the cloud because of how much of a pain it is to actually deploy up there right now, that's going to get made easy. And I think we'll see a lot more people adopting when that happens.
Yeah. And playbooks, we're creating playbooks with AWS as a partner to help with the hybrid multi-cloud solution, some of that migration for use cases as well as for the XenApps and desktop use cases as well. So one thing I want to highlight is the recommended deployment scenarios with the clustering. Clustering is actually a key feature in the autoscale. That's really our differentiation. As you know, we've had autoscale clustering for many, many years. So leveraging that to autoscale was an important piece.
Who can tell me why 32 is the max number of items in a cluster? Well, that doesn't shock me. Anyone?
Anybody?
Anyone? It has to do with the routing issue. Oh, who?
Oh.
Carl, was that you?
Yeah.
Yep. 32 is the max number of nodes in an ECMP
Oh,
group.
that's a good job. Okay, good job. So, and then licensing, of course, with our pool capacity would be that differentiation as well. So a lot of this, I really want to highlight your key takeaways. These are the ones, and we have the many documentations for you to have. And then before you leave, make sure you do the survey. And we need to be rock stars in order to come back next year. So 5 stars only, okay? Unless it's, you make a comment, about Netscaler. Good 5 stars.
1 stars gets Marissa fired. Just throwing that out there.
Yeah. Rate this session, please. In this, I think you guys have all the same app. And then tweet about the session if you like, as well as the Synergy in general. We see a lot, obviously, in the keynote. And then all the rest of the sessions that are available for you guys, Cloud Native. It was a big hit yesterday as well as today. So hit as many of that, what he talked about on Kubernetes. That's a popular one. And obviously, if there's more sessions tomorrow, I even have a session that's happening at the same time right now with the ADM, and that's why we only get half of the people here. But it's good that you're all here today.
Yep.
And
Any
with
questions?
that, we'll have 3 minutes for Q&A.
If you got a question, you got to go to the mic. Sorry to be
Yeah.
embarrassing, but it's a requirement.
Make it a good question.
No stump the chumps.
Oh, stump him.
Don't stump.
Yeah.
Anyone?
Any good one?
Anyone? Bueller?
Come on.
Yeah. Yes.
Okay, go ahead.
GSLB make you Netscaler, I still call Netscaler,
Yeah.
aware of which one is closer to you. But how do you make the Netscaler aware of which back-end application server is closer?
So what GSLB is going to do is it's going to look at your LDNS server, and from that LDNS server's IP address, do a geo-IP location. So assuming you're geolocated with your LDNS server, you should be able to get a resolution that's to the site closest to you. The DNS resolution could happen anywhere in the world. If you have 50 Netscalers playing in the GSLB cluster, you're going to get an answer from one of those 50. But the answer that comes back, assuming geo-IP is being used, should be the closest Netscaler to your LDNS's IP. This is where the problem is. If your LDNS happens to be 2,000 miles away from you, you're going to go to the site that's 2,000 miles away from you. What ITM does is it takes all of that out of it, and it knows the actual user's data based on the tag information that we're sending. And so it will be sent to where the actual user's closest site is. But it isn't necessarily the closest site. It's going to send you to the fastest site. So if the fastest site happens to be on the East Coast because there's some congestion on the West Coast, or the fastest site's in Singapore because there's some congestion in Japan or China, it's going to send you to that fastest site regardless of your location. And that's the advantages of ITM.
More intelligent.
Much more intelligent. Okay. We call it intelligent traffic manager for a reason. Yeah.
Now, the video, we do have a demo, but because of time, we could just append it into the slides so you can have it to download. Okay?
Also, it's available on YouTube. You
Let's
can.
backbone on his question. Let's say that you've got your private data center and you've introduced cloud and you're wanting to do primarily load balancing to your primary data center, but slowly drive traffic to your cloud services. How would you do that?
So you do it through percentage-based GSLB. Is this public or private?
Well, one would be a public data center, one would be a private.
Right, but I'm saying, are the IP addresses available on the internet, or are they only? Okay, yeah. So you would do a percentage base. So you would say, I want 90% of my traffic here, 10% of my traffic there, and so 90 out of 100 A records would be one site, and then you just start switching those percentages until you get 100 somewhere else. Okay. Yeah. So it's actually very easy to do. One of the nice things about DNS is it's very mutable, right? So I mean, you can change things and manipulate things very easily.
Could you do that across 2 different cloud platforms?
Sure. Yeah, you can.
So all the rules remain the same regardless of where it's at?
Exactly.
Okay, great, thanks.
We did a ITM masterclass on that last month, and we did exactly that cloud migration.
Okay.
Actually, if we've got a
Okay.
video of our canary stuff, you should go look at that because that might actually help with that thing too.
All right. Thank you. Thank you very much for coming.
everyone.
Thank you all. Appreciate it.
We'll be on the demo floor.